Bismillah, Assalamualaikum warahmatullahi wabarakatuh, and good greetings. This will be statics on demand. We would say that. Basically, this is a question asked by one person that commented on one of the statics tutorial video, asking to solve this question, right? So this is the third time I think that I have ever responded to a request with regard to statics question, right? So the diagram is as shown. Unfortunately, the diagram given is in a quite small file that is quite blurry. Hopefully it still can be understood, right? This is a structure. I believe this is a frame, right? So basically this is from chapter 6 normally, from frames and machine, right? So the question, because initially the one that commented asked how to calculate the force F, as well as the reaction at D, at I, and at M, right? So if you are looking at the diagram here, so this 2 Newton is given acting at this point A, and then this F is unknown, so we have to find F, and then we have to also find the support reaction at point D here, point I, where is point I? Point I here, and also from M here. So that is what I understand from what is being relayed to me, right? So it is interesting that this, I'm assuming he is a student somewhere. Actually this is the third. From the name, I assume it's from, I do not know what is to assume, but in terms of the language here, it is from, I don't know, is this Portuguese or Spanish? But it's from one of those countries, right, that use that language, I assume, right? Because before this, I think the first ever request on YouTube is from the Philippines, if I'm not mistaken. Second is from Iraq, if I'm not mistaken. So this is from a different continent altogether. But anyway, so let's address this question. Now, if you look at this question, my first question is this to you, be it you the one that asked this question, or if my student are watching this, right? Of course, if you're my student in this semester at this current point when I'm recording this, you haven't learned up till this point of this chapter yet, right? Because this is chapter 6. It's in the future. If you are watching this before the final exam, then you should know how to solve this already, right? Now, I noticed that many students, when they see diagram like this, then they become afraid. This is so difficult, this is so complex. But actually, if you have done several questions like this, you will notice that this is actually one of those easy questions. We will see. It is easy. Honestly, if you see something like this, normally the calculation is not as long as you initially thought it would be, right? Now, the first thing that you have to understand what you need to do in this kind of problem is to identify what are the members and how are they connected to each other, right? So if you can see here, all of these are connected between one another by pin, right? For example, we start from here. This is pin, 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 right? All of those are pin. So when we have this kind of, so this is a frame. So the first step, so I'll note the step by step on this Microsoft Paint here. Hopefully I can save as a picture and you know, attach it later. So the step number 1, if I would say it, is identify two force members, right? So that's number 1, because that will change the free body diagram entirely. If you can identify two force member, then if there's a lot of two force member, then it will become much easier actually, right? And by looking at this, you will notice that there's a lot of two force member, right? Hopefully by now you understand what is a two force member, how to identify, and what is the implication, right? So okay, let me use this one because I want to sketch on this picture as well, right? Because Okay, let me bring it over this side. Okay, so let me use the purple one. All right. Oops. So it is okay. I will have to adjust it a bit. Okay, hopefully that is still within sight. All right. Now, let's identify the two force members, right? So we'll begin from this point here. So, okay, this one, can you notice this? This BE is two force member. This one, this BE, this is two force member, right? So we have, oops. So I'll in an answer here. Let me choose a blue. Right? So two. Anyway, force members. So member BE, that's one member there, and then take a look at this. Can you identify that HF is two force member? This one. This is two force member as well, right? HF. Okay, we will identify in the diagram first before we go and note them down. And then I believe this, because this is not that clear, but this is, I'll use a different color so that it is, yeah. So this one, this is two force member as well, right? And if that is correct, because I'm not, because the line is not quite clear in the diagram that I've given, so I'm not sure whether JHG is one member or it's combination of two force member. But from the look of it, this is one for two force member GH, and also it's connected to, let's use a different color here. So this one is two force member as well. HJ, oops, that is two force member as well, right? If you look at the original diagram, IJK is one member there, right? IJK is one member there, and then let's use a different color then. This KL is two force member, right? KL, and that's it, because LMF is one member, a long member there, right? So if we take a look at all the two force members, so you have this one EB BE. Okay, so we have 1 2 3 4 5 two force member, right? So if I'm to write here, so BE and then HF, oops, member, and then GH, and then HJ, as well as KL, right? So now, why is it important to identify two force member? Because we know when we have two, oops, sorry, the drawing is so bad. We have two force member, for example, something like this, at this point where the force is. So there's only two possibility, right? One is if it is under tension, right? Another possibility is it is under compression. There's only two possibility. There's no X and Y to consider. It's always along the these 2 points, right? Right. So okay, to erase this one, this might delete. Okay. Right. So after knowing that, we will go to draw free body diagram one by one and then solve bit by bit, and we will see whether this is difficult or not in general, right? So first we will always start, the easiest way is always start with what you have and can calculate, meaning that start where the value is given. In this case, the value given here, 2 Newton, right, at point A. So we will consider point member A, B, C here, this member. So if we draw, so step 2, oops, let's use, should I continue to use just black? Is it better like that? So step 2, step 2. So free body diagram of member ABC. So if you draw that, okay, it's hard to draw on this thing, but hopefully you can bear with me with the bad drawing. At least it is understandable, hopefully. So you have, so I'll draw the forces in red. Is it better in red? Okay, so I have here, this is given already, 2 Newton. And then, okay, if I have a point, right, so this is point A here, and then we have point B somewhere here, point B, and then we have point C here, right, point A here. This is point C. All right, so we'll draw the force in red, right? So why is it important to know BE is to force member? Because the force will be along BE. So we can assume either tension or compression. So I will assume it as such, right? So let's say this is FBE. So it will be along the member BE, right? So if I am to draw the corresponding two force member here, right? Corresponding to force member of BE here, right? So this is B, this is E. The corresponding force of what I'm drawing here will be something like this, right? FBE, FBE, right? So at point B here, this is the corresponding forces, right? It is under tension. Okay. So and then I can assume here, this is just assumption. So Cx in this direction, and as well as let's assume Cy in this direction. It's just an assumption, but it is an educated guess, right? Because if I say later on I want to take moment about point B, obviously this Cy have to counter this 2 Newton sort of to balance, if that assumption is correct, right? And then the dimensions. So of course the free body diagram have to be completed by the dimensions, the needed dimension. So here from A to B you have 65 plus 10, meaning 75 millimeter, right? All the distance is in millimeters. Okay, millimeter. And then all here is what is 30 plus 10 plus 10, 30, 40, 50 millimeter. Yeah, is it clear that 50? Let me make it clear. 50 millimeter. All right. So that is the free body diagram of ABC, right? From this free body diagram, so we'll just, okay, here. So from this free body diagram, we can, what is the easiest way? Do we need to solve for C? No, right? So if we do not need to solve for C, then I don't care what is C. I just want FBE, because then I can move on to the next member, right? So we can do that. Summation of moment about point C equal to 0. So I take moment about this point C here. I'll take counterclockwise as positive. So if I do that, taking moment about this one, obviously Cx and Cy will produce 0 moment. So FBE is counterclockwise, so it will be positive. So FBE time distance of 50 millimeter, right? And then 2 Newton is clockwise, so it becomes negative, then 2 Newton, and then the distance is 50 plus 75, which means 125, right? 125. This should be equal to 0, right? So then you can solve. So FBE is, if you have 2 times 125 divide by 50, you get 5. So FBE is basically, where's my okay, this one, 5 Newton. So now we have solved FBE. Now because FBE is solved here, so this one, where's my mouse? This one is FBE. Can you see this? The same here, the same here. So we can go to now member FED or DEF here. This member here, right? Hopefully you can see my mouse. Right, so that would be step 3. We go to the next free body diagram. Alright, so step 3. So we draw free body diagram. Basically we solve the member there, right? Of member FED, right? Or DEF, whichever way you want to read it. So it is basically this one, right? Over here in the diagram. So it is shown that the 3 pins is horizontally on the same line, right? So regardless of the shape, even though the shape is curvy a bit, but essentially the pin is on the same line, right? So I can just draw something like this, something like this. As long as the pin is at the same line, so we can consider it as such. Okay, even though the drawing seems like that, but consider that a straight horizontal line. Okay, so that is, this is F E D. Now from the force, okay, let's go here, right? So from this FBE, which is known as 5 Newton, so the corresponding force, okay, I should have done, is this one, right? FBE, right? FBE. Okay, we know already the value, it is 5 Newton, right? So that's known. And then at point D here, it is spin, so we have X and Y component. So I'll label this dx and I label this dy. And then, okay, interestingly, at point F, because we have understood that HF is 2 force member, so the force will be along that line, right? So it will be along this one, so we'll label it F H F. The angle will be, okay, the angle will be interesting here, so let's consider, okay, I'll erase this one. So the angle here, if you consider this triangle, right, this triangle here, it is this one 10 here, and the height is this 17 here, right? So the angle would be, if I'm using this color now, it will be, what is it just now? 10, right? Below here is 10 and this one is 17, right? So in terms of the triangle, if we have 10, 17, what do you have there? 10 square plus 17 square, 389. So it will get square root of 389. So that will be this triangle here, the angle there, right? And then we have the distance. So let's just use the distance. This is what? 10 and 10, right? 10 millimeter and 10 millimeter. Oops, meaning this distance here and this distance here, right? Am I correct here? 10 and 10. All right. So this is another simple, straightforward. Of course, early on, okay, what is the question 1? So I have to mark here first, right? So let's because the question actually want, in this particular question, if I understand him correctly, what is F? Yeah, what is F? And then what is because the question 1, the support reaction at point DIM. So meaning what is dx, what is dy, what is ix, iy, and then mx, my, right? So this what we need to solve. So considering this, so point D, we actually need dx and dy. All right, so here we actually want dx and dy. right? But regardless, we can solve which one first depending on which is easier. So I'll just solve HF first, right? So from there I use summation of moment about point D equal to 0. If I take counterclockwise as positive, so it will be this 5 Newton, so 5 Newton times 10, right, clockwise, counterclockwise, sorry. And then we have the vertical and horizontal component. Of course, the horizontal component, it goes to point D, so no moment. The vertical component, it will create clockwise, so become negative. And then the vertical component is FHF 17 over square root of 389, this triangle there, right? And then the distance is 20, right? The whole distance 20. That's the only force, so equal to 0, right? So based on this, we can calculate FHF equal to something, right? So if we calculate that, so 5 times 10 over there, 50, and then divide by 20, and then how to do this? Multiply by square root of 389, and then divide by 17. So you get 2.9. So you get 2.9 Newton FHF, right? Now we need to calculate dx and dy. So from here, after we have established that one, we can continue on this side. So I'll use this one, even though it's upper side, but it's continuation. So summation of fx equal to 0. Let's take to the right as positive. So we will have dx minus FHF is 2.9 just now. So 2.9 then 10 over square root of 389 equal to 0. Right, so dx will be 2.9 times 10. Is that 10? That seems like bad shape 10. So it's 1.47. So 1.47 Newton. So because the question actually asked for this, so this is one of the answer. And then we do summation of Fy equal to 0, taking upwards as positive. So I'll have dy minus 5 Newton there, and then plus FHF is 2.9, and then 17 over square root of 389 equal to 0. Okay, the space is okay. Hopefully you can still see those numbers now. So it will become 5 minus 2.9 times 17 divided by square root of 389. You get 2.5 dy. Where's my mouse? Where's my dy equal to 2.5 Newton. So that's another answer. So that's the first set of answer that we have managed to calculate, right, for dx and dy. Alright, so we get that from this free body diagram, right? So we have solved at D. Now moving on to the next part, right? So now we know we can move to member FH. But member FH is, if you draw the free body diagram, because it's straightforward, it's two force member, right? So it's straightforward. Okay, where should I draw? Okay, from here, right? If I draw the two force member here, so it will be shaped like this. If I draw here, something like that, and then the force will be just simply like this, right? FHF, which is now we know as 2.9 Newton there, right? So it's just straightforward. So we can go actually to okay, now this is get interesting actually, right? Because if you look at the diagram on the right here, if HF is two force member, GH is two force member, right? From the look at it, it's like that, right? Because it seems separate member than GH, right? From the way I look at it, it is actually two separate member, right? And then GH, right? So meaning that the pin at H is connected to 3 different 2 force member, right? So you can use the method that normally we use for trusses, right, where we focus on the pin. So this is already step 4, right? So okay, black. Step 4, free body diagram of a pin H. So I'll draw that one, right? It will be something like this. This is pin H. So I will have the 3 forces, right? One force is from HF. So HF is in this direction, so the corresponding will be in this direction. This is F, H, F, right? And we know already the value is 2.9 Newton. And then we'll just assume GH in this direction. So this F, GH, and then we'll assume this in this direction, F, GH, F, OHG, whichever arrangement. Alright, so that will be this one, and then the angle is still that triangle just now, right? So this triangle here, oops, is basically what? It's 10, 17, and square root of 389. Basically the triangle will become like this, 10, 17, and square root of 389 just now, right? That is the triangle. Okay, so if you understand the corresponding, so I'll draw the corresponding members, right? So meaning that over here is that 2 force member here, over here is 2 force member here, and over here is the 2 force member here, right? Where each of this, so I'll draw in a different color, I guess. So here, this is the corresponding force. For this one, this is the corresponding force. Okay, my drawing is become worse and worse. This is the force, right? Okay, so but we do not need to show that one, but this is just to illustrate if anyone want to understand what is the meaning of the free body diagram of the pin, right? And we are focusing at the free body diagram of the pin here. So from here, what I'm interested to is to go from, okay, if you look at the diagram on the right here, right, I want to get from 2 Newton up all the way to F, right? So we move bit by bit. So now I just interested to know what is F, H, J, because I want to move to the next point, right? So that's what I'm only concerned about. So I don't care about F, G, H. Why should I care? So I'll just want H, J. So then I will do summation of force in x direction equal to 0. Let's say to the right as positive. So we'll have this one FHF of 2.9, and then we was the horizontal component, right? So 10 over square root of 389, that's the horizontal component, and then minus FHJ equal to 0. Then you can calculate FHJ equal to 2.9 multiplied by 10 divided by square root of 389. You will get 1.47 Newton, right? So now we can go to this member IJK, right? So it's a weird shape there, but regardless. So step number 5, is it step number 5 or what? Step 5, right? So step number 5, free body diagram of member IJK. So the shape is somewhat like what is that? Something like this, something going down, something like that, right? Fair enough, I guess. And then if we have the, we're going to mark the point, this is point J, this is point I, and this is point K, right? So in terms of the forces, so point J of course is corresponding to the previous force, right? So this one, FHJ corresponding to this one, corresponding to this one. So if you draw the corresponding force, it will be in this direction, right? Where we have the value here, 1.47 Newton. That is determined before, right? And then if we have okay, at I we have x and y component, right? So if I assume this is I x, if I assume this is I y, right? And then at KL, because we already identified as well, KL is two force members, so we can just assume it is to be under tension, right? So FKL. Now this means what? This is the assumption, so I just draw something here. The assumption is this FKL is, I'll draw this one, is something like this, right? The two force member. So with this assumption, it's meaning the corresponding FKL is in this direction, right? So no angle needed. What is the distance? So we have the distance of, this one is 17 millimeter. This is 17 millimeter, and what is that? That 14, right? This vertical distance is 14 millimeter. Yep, that is what is needed, right? And going back to the question, I think I is needed, right? So we have here, we need to find Ix and Iy. All right. So for Iy you can solve straight away because there's only one vertical component, vertical force. So if you do summation of Fy equal to 0, taking upwards as positive, what you'll get is Iy equal to 0. So this is one of the answer, right? Now for Ix, so I will which one is easier? Okay, if we take summation of moment about point K, well, summation of moment about point K. Okay, let me do summation of moment about point K equal to 0 if I take counterclockwise as positive. So I want to take moment about this point K. So counterclockwise. So this 1.47 will be counterclockwise, right? So 1.47 times distance of 14, and then Ix is clockwise. So minus Ix is, we do not know the value yet. Okay. Okay, and then the distance is 17 plus 14, 27, 31, right? 31. And because Iy is 0 already, right? Iy is 0 already, so it doesn't produce anything. So this should be equal to 0. So based on this Ix equal to 1.47 multiplied by 14 divided by 31, you get 0.663. Is that correct? 664. 0.664. 0.664 Newton, right? Newton. We need to provide the answer as well, right? Okay. Yep. So you get that answer. Now to find FKL, because we want to move to the next point, so you can use summation of Fx, or you can use moment about point I, right? But here, because I already have Ix, so maybe I can try summation of Fx equal to 0, taking to the right as positive. So you'll have 1.47, and then minus Ix, just now you already have 0.664, and then as well minus FKL equal to 0. So from here, FKL equal to 1.47 minus 0.664. So 0.806 Newton. FKL. Okay, so now we are moving to the final member here, right? Because we have drawn already the two force member KL here, right? It's not important for calculation. We know it's two force member. So we go to step 6. Step 6, free body diagram of member LMN, right? So how to draw this? This is something like this one to here to somewhere here on a platform here, right? Something like that. Okay. Something like that. I hope you can relate between the two, right? Ignore the bad drawing. So this is point M, this is point L, and then this is point N, and then we have the force F going down, F, and then at L here we already know, because we know the direction there, right? So this one here corresponding to force should be to the right. So what is the value? 0.806 Newton. M is a pin, so it should be X and Y, right? So if I assume this MX this direction and MY this direction, right? MY MX. It's not really an assumption because we can see the other force. We know it should counter that one already, right? So we can make an educated guess. So in terms of the distance, from M to F is 68 millimeters. So 68 millimeter from this to this, and then we have 12 millimeter in between this, right? 12 millimeter. Now do we need to solve M? We need to solve M, right? Yeah, we need to solve M and as well as F. So I will solve F first because that's the easier one in my opinion. So I'll just take summation of moment about point M equal to 0. Let's take counterclockwise positive. So from here we have that 0.806 distance of 12 counterclockwise, and then F is clockwise, so minus F, and then the distance is 68 equal to 0. So F, you'll get the answer of 0.806 multiplied by 12 divided by 68, 0.142 0.142 Newton. That is the answer for F. Should I go down? Okay, I'll use on the side here, right? Because we already determined that one. So if you do summation of Fx equal to 0 to the right as positive, so you'll get 0.806 minus mx equal to 0. So it's straightforward. Mx equal to 0.806 Newton. And then if you do summation of Fy equal to 0 upwards as positive, what you will have is My minus F. F is already calculated as 142, then equal to 0. So My equal to 0.142 Newton. That is the answer. Right, so we have solved everything, right? So yeah, I think if you have gone through all of this, you'll notice that, wait a minute, it is not difficult, this question. It is not, because when you have a lot of two force member, it actually simplifies the how to solve, because When you have two force member, you do not have x and y component. You will just have along that two force member. So from here you can see that these two force member, this, and these two force member. So it is easier than expected. If you expect this question to be difficult. If you have done enough exercise, you will know that just by looking at it, this is not difficult, right? The only thing is you have to avoid mistake. I'm not sure whether I have managed to avoid mistake or not. Please do verify all of the numbers. I'm not, because this is just me doing straight away here, right? So that's it. Hopefully it has been helpful, especially for the one that asked this question. Hopefully you understand the steps. So whatever type of diagram or structure that you have after this, you know what to do step by step, inshallah. With that, thank you. Hopefully it helped, and all the best in your study. Wassalamualaikum warahmatullahi wabarakatuh, and see you next time.